Hello and welcome to the video. Today the video is going to be about 4 of the most common data career paths, the skills and responsibilities of each one, and overall there's a huge growing demand for data professionals in the world right now from my perspective, as more and more data is getting created daily. And I think in 2023 there was like 2.5 quintillion bytes of data created every day, something like that, like an insane amount of data is being created. And so now, more so than ever, in my opinion, is a great time to start a career in data. So let's get started. Number 1, data engineer. So data engineers, their primary goal and responsibility is to build and maintain pipelines that can pass data from raw sources into your data warehouse. So they build the infrastructure and internal tools that allow data to be collected, stored, processed, and sent from external locations to internal locations to then make available for other people like data analysts and data scientists to then use that data. Additionally, depending on the role of the company, sometimes data engineers are the ones who build the data models for your company too. Sometimes, now there's a new-ish role called analytics engineering, which does the data model building. But historically, before analytics engineering came along, it was the data engineers who, after piping in the raw data from your raw sources like Facebook, Google, into your data warehouse, would then build easy to use data models that then data scientists and data analysts could get data from. So the key responsibilities of a data engineer are building and managing data pipelines, 1, 2, sometimes often designing and maintaining databases and data warehouses. So generally, it really depends on the company, but often data engineers are responsible for the entire database itself or the data warehouse system as a whole. So the scope of a data engineer can be kind of wide. It can be from the beginning initiation process of getting raw data to owning the full data warehouse as well. And then third, ensuring that the data quality and the data governance is up to par. Often, data analysts and data scientists will expect the data that you get from your warehouse to be good to go, and the primary responsibility is usually in the data engineering realm to make sure that the data that's being served downstream to data analysts and data scientists is good to go, ready to use, has been tested to ensure that it's not faulty in any ways, not missing nulls, not having errors in the data, or overall making sure that the data is in a state that can be used. Then, of course, finally, 4, integrate data from a ton of external sources via APIs, webhooks, data connections to integrate these external data sources and the data from those sources into your one central data warehouse. So let's break down the skills that would be needed to be successful as a data engineer. The top one generally is Python. Python, because you're building all of these data extraction jobs, that's generally used in Python and hosted in Airflow. And so you need to be good at writing Python to talk to the external API to know which data to get, which data you don't need to get, how to format that data, and how to structure that data in an Airflow job that can then be run on a schedule to process and dump new data from that external source into a data warehouse, usually on a nightly cadence, like every day. The data is going to be extracted, updated, and refreshed. And all that logic is done and held in the Python scripts you use to extract data from the raw source to your data warehouse. Another skill that will be needed is database management. Data engineers generally need to know the most, more so than data analysts and data scientists, about how to navigate the data warehouse, whether you're using Snowflake, BigQuery, any of the big cloud providers. Generally, data engineers are the go-to person for any database issues. So not only do you need to be good at SQL for testing queries, writing data models in DBT using SQL to do that, but you also need to know kind of the under the hood logic of how databases work, how cloud data warehouses work, and how to process large amounts of data. So overall data management skills are super important, and the main tech skill there is SQL. SQL is going to be how you navigate accessing and checking data in your data warehouses. And then kind of on that note, another skill that's important is Spark, or some technology that is used to help you process large data sets at scale. Often Python and SQL inherently, without using Spark, can only handle so much data effectively, and you need to leverage a tool like Spark, which is really you can plug in Spark, which can help you process big, huge data workloads in a distributed system. So basically, not all one core of your computer is processing all the data. You can partition up your compute strength to run multiple jobs at once, so you can run things in parallel. Won't get into Spark in too much depth now, but it's an open source tool that you can use for free. And you can use Spark in Python with PySpark, and you can use Spark very easily in your SQL queries as well too. Then last main skill I'd say a data engineer needs to have a good understanding of is some cloud platforms, because often when you are passing all of the data from your external sources into your data warehouse, you may need to go through some cloud platforms like AWS, Microsoft Azure. You don't need to have as much knowledge as an internal IT member, but you should have enough knowledge to be able to deploy jobs. Basically, what you need to do is you need to deploy. Sometimes you may need to deploy your extraction jobs in these cloud platforms. And so having a good understanding of how cloud platforms can work can really help you be effective in executing and hosting your extraction jobs. The overall tools a data engineer will really be working with is like an ELT, your ELT processing, data processing system. So that's your extract, load, transform data process, which now ELT is, in my opinion, a lot more common now than the ETL system. So in your common day-to-day life as a data engineer, you'll probably be working on optimizing or writing new ELT processes to integrate new data into your data warehouse, and then two data orchestration tools, which sometimes can be cloud-based, but often is also based in Airflow. So you can run your data extraction jobs in Airflow. And what a data orchestration tool is, it is really just like a cloud-based tool that you can use to execute your scripts, your Python scripts, your data extraction scripts, to then kick off runs to get new data, update data from your source data system, think Facebook, and then reflect those updates in your data warehouse. And the overall reason why data engineering as a field is important is because the data engineer and the data engineering team is responsible for providing clean, accessible, and accurate data downstream to end stakeholders or downstream to the other teams to pick up on, so that the data science team and the data analytics team is using good data to build their work on top of. For example, if a data science team is using data that is unreliable, pretty much any model that they're going to create is going to be bad. And the reason it's going to be bad is because the inflowing data, the incoming data, was bad. And it's the job of the data engineer to ensure that the data that you pass to the data scientist is good to go and ready for modeling. The next common role we're going to talk about is a data analyst. The overall responsibility of a data analyst is to use data to analyze and interpret that data to make organizations or teams like marketing team make better decisions. And the way that they do that generally is usually through ad hoc analytics projects, if it's just like a small segmented project you're working on, as well as making dashboards sometimes too in like a BI tool to make reports that other teams can use to understand how the business is operating. But the overall responsibility of the data analyst is to use data and analyze that data to help the business overall make better decisions. And so key tasks that the data analyst team usually does are: one, analyzing data, as you may guess. Sometimes you do need to clean and process the data even a little bit more after you get that data from the data engineering team. Like you may want to add some business logic in your data, and you can do that by creating your own data analyst models in a tool like dbt or so sometimes after the data has been served from the data engineering team to the data analyst team, the data analysts may want to do even more processing on top of it to then add business logic that they can then use to use that new business logic in a report or in a dashboard that you then send to like a marketing team or so. Second key responsibility for the data analyst team is to make reports and dashboards that are easy to use for external non-technical team members to communicate findings, communicate insights from the data, and also make reports and dashboards that are downloadable by, like, say, marketing operations team, and they can do a quick analysis on that data that's downloaded to get the last leg done. These would be more like self-service dashboards. And then third, another key responsibility is solving ad hoc business problems using data. So often this could be something like you may want to analyze, say you have a good season selling widgets on an e-com company, you may want to do a post-mortem where you identify return on ad spend values for your different marketing channels. And this could be an ad hoc task that a data analyst could do by bringing in data from all your marketing sources, cross-mapping that to your sales data, and then doing an aggregation and then making visuals of how much ad spend was on a given channel versus how much sales we had during that channel within a certain period of time. Okay, some of the skills needed to be successful as a data analyst would be SQL. Number one, a data analyst spends a lot of their time in SQL hitting the data warehouse to do ad hoc queries or using SQL in your BI tool to make dashboards, which leads me to the second skill. So after SQL being number one, second skill I'd say would be a business intelligence tool. So this would be something like Looker. Basically, this is just a tool that you can use to make very nice dashboards and reports that other team members can then like poke around and find their own insights out of. So this would be like making graphs and charts and serving the data in a platform that users can then filter in the date range function, do drop down filters to specifically get to the data that they're looking for. Additionally, data analysts sometimes work a lot on A/B tests. And so when you're working on an A/B test, it is important to have a good understanding of stats and statistical knowledge. And so in addition to SQL, a BI tool, I would recommend that stats, a good understanding of basic math and statistics is important so that you can interpret the results of a A/B test correctly. And overall, why data analysts are important in general is because they kind of bridge the gap between your raw data that is served to you from the data engineers to then data analysts take that raw data, add business logic to it so that you can turn that data into insights that can then be used for other teams in the business. Okay, now the third data role we're going to talk about is the data scientist. And really what data scientists do are they do the harder problems than what is given to the data analysts. So some of their tasks can be uncovering super hard to find trends in the data by using machine learning and advanced maths combined with coding to create models that can either predict future outcomes or identify really hard to find trends that may not be available just by using SQL in your data. Key responsibilities of data scientists are building machine learning models, doing really thorough exploratory data analysis using Python, which can also be combined with some AI libraries to identify patterns and relationships that may not be super easy to see. And then often nowadays, a lot of data scientists work in predictive modeling too. So companies want to see what's going to happen to the future. And so what often happens is a lot of data science teams work on building models to predict how the business will work in the future or how something will perform in the future based off of historical data that you have. This could be something like predicting customer behavior if a new feature was to go into place. This could be something like predicting sales expectations by doing some regression forecasting, and all that to something a lot more complex using machine learning algorithms and AI. It's the scope of hard business problems to anything else. It often falls under the realm of data scientists. So it's a very big field here. And then the fourth kind of key thing is they need to be able to communicate these really technical findings that they do to non-technical stakeholders in a very interpretable way. And this can be often even more hard, even more tricky than some of the technical problems. So say that you built a neural network, which is really like a black box methodology. You need to be, and the neural network is spitting out recommendations, like product recommendations that are going to be served on the website. You need to be able to explain the technical functions of what is happening on the back end in a non-technical manner to the higher ups in the company or other teams so that they can understand at a high level what is happening in the model without necessarily needing to get into the nitty gritty of the exact software engineering or coding at all. Okay, so data scientist skills. I mean, off the top of the cuff, it's certainly Python. Python is the most common language that data scientists are going to code in. Secondly, I would say machine learning algorithms and understanding of how the machine learning math works. So nowadays, there's a lot of libraries that data scientists can use to really help do some of these advanced mathematical functions and apply that to your data. But you don't want to just willy-nilly apply these functions to your data. You want to understand the actual logic that is going into the actual logic and a high level of the math of what is being done to your data so you know exactly what to do. You don't want to just as simply just call a modeling function on your data. You need to really understand under the hood what the parameters you need to enter are, and then what the implications and biases that are happening to your data by using these machine learning libraries are. So you need to have a strong fundamental understanding of machine learning mathematics and how these functions work. Which also kind of leads into the next skill. I think you need to really have good advanced statistical modeling. Ideally, you should understand Bayes theory to a degree. Definitely have a very good probabilistic understanding of statistics. and because this is going to be really important for interpreting the results of your machine learning models. Often you'll get spit back a bunch of output variables from your model that will tell you how the model is doing. You really need to be able to understand how to interpret these R squared, p-value, and even a lot more complex performance aspects of your model to really understand how effective the model that you're creating actually is. And then the last skill I'd say is feature engineering. If you're doing a lot of modeling too, you often have to work with your raw data, wrangle that data, to be able to create good features that you can then feed into your model. You often can't just feed in your base data to whatever model you're doing. You need to do feature engineering on top of that base data to then create good features that can then be used to create good results. So a lot of the tech that is used in data scientists are the machine learning models such as TensorFlow, scikit-learn. Those are the big frameworks I'd recommend to learn. And then secondly, the data wrangling piece. This is also where you're going to use a lot of pandas for kind of formatting the data before you feed into your model, and then NumPy for doing matrix multiplication as well. If you need to do handle matrix math pretty fast, NumPy is great for that. Data scientists are often important in a company because they are given the hardest problems to solve. They are often thought of as like the problem solvers. So by using data and math to make models and predictions of what's going to happen. And so you need to be able to appropriately know how to use and deploy these machine learning frameworks you're using to actually get good results to be successful as a data scientist. Because if you don't know what you're doing, you're just not going to be creating a good output and end up looking like a fool. And that's not what you want to be doing. Okay, so now we're on to the fourth and final data role that I added just at the end because I was thinking a little bit more. And I think this role is actually more important than it gets credit for, and that is the business analyst. And so, what a business analyst really does is their role is to sit between the business needs and tech and best interpret data insights that can help drive a company forward. And so what they need to do is they need to have a really good understanding of how the business works. They need to have a really under the hood understanding of like what drives the business forward from a revenue and cost perspective, or even operational efficiency perspective. And then they need to be able to interpret data sometimes that is served to them through data analysts, or even investigating the data themselves in the data warehouse to identify opportunities to improve things in the business. And so, whereas a data analyst who is usually just serving data to an end stakeholder or doing an ad hoc analyst to answer a specific question, the business analyst is the one who takes a much more broader problem, breaks it down from the business standpoint, and then tries to identify areas of opportunity to improve. So, for example, let's give like an overall example of what a business analyst might do. Say that you are shipping products and you historically have only shipped products through UPS, FedEx, and USPS. The business analyst overall question they might be trying to solve is like, hey, how can we get our shipping costs lower? And so the business analyst would start by understanding what dictates shipping a product in one of the three carriers, and then they could look at the underlying shipping data to say, what shipment carrier is the cheapest? Is there an opportunity for us to do more, to send more shipments with the cheapest carrier? And why have we not been doing so already? And so basically, they start with a high level problem, and then by using the base data, often in Excel and SQL, they try to answer the overall question. In this case, how can we lower shipping costs without having an impact on customer happiness, by seeing if there's opportunity to maybe lean more into one shipping carrier that might be cheaper, but for whatever reason we hadn't been using that cheaper shipping carrier in the past. And so that's just an example. And that's really where they differ from from data analysts. They start with a higher level business question. They're a lot more closer to cross-functional stakeholders in the company rather than just working on dashboarding and reporting all day. And then after they get the high level question, they use the data to help understand what the current status of the situation is, and then investigate how, from the data that we have, can we maybe close a inefficiency gap, either cut costs or make the business more efficient. Let's talk about the skill sets needed for business analysts. One is communication. Often you're going to be working a lot more cross-functionally with different stakeholder teams to really understand these overarching questions you're trying to solve. Two, you need to have a really good understanding of how the overall business functions. Data analysts, on the other hand, don't need to have that thorough, deep, rich understanding of what the main drivers of a business are. But for business analysts, they need that because they're going to be trying to improve overall functions in a business. Three, you also need to have some tech knowledge too. Like you need to be good, usually just at SQL or interpreting data from dashboards. And then four, you need really good communication in terms of translating technical insights from the data you get to non-technical stakeholders. So this is also where you act in the data science realm of communicating the results that are given to you from data to non-technical people. So the tools needed to be successful in this. Tools in tech, one, SQL, and then two, another business intelligence tool like Power BI, and then maybe like a process modeling tool like Lucid Chart to really kind of draw out each part of the business to see what's happening at each step in the business from like manufacturing all the way out to customer shipment so that you can try to identify the inefficiencies or zoom in just on the one function of the business that you are trying to improve. And so overall, why business analysts are important is they really are the ones who help make data-driven decisions by ensuring that the business requirements of whatever the business is doing aligns with the data strategy, and then also looking for the opportunities of how to improve different business functions by using the data that's available to them and identifying inefficiencies. And so these are the four, in my opinion, most common data roles that you'll see now. May also see analytics engineering going forward in the future. And analytics engineering really is the role that is just doing your data modeling. So sometimes when the data engineering team does modeling, or even data science or analyst team does modeling, the analytic engineers are the ones who do all your modeling to make very good data models after the raw data has been loaded into the warehouse, who then serve to the data scientist and data analyst. A lot of that is done in a tool such as dbt, but they're still pretty rare overall. And so to summarize, if you want to get into data engineering, learn programming, database management, cloud computing, and then cloud-based data tools. If you want to become a data analyst, get a strong foundation in statistics, really understand SQL very well, and understand how to make very good data visualizations in your BI tool. For data scientists, you really have to work on advanced mathematics, understand the core concepts of machine learning, be very good at Python, and then be very good at interpreting and communicating very technical based results to non-technical stakeholders. And then for business analysts, you really got to be good at understanding the business as a whole, the business requirements, the business goals, married then with some basic data analyst tools such as SQL, interpreting results that are served to you in a BI tool. That, in my view, are the top four most common roles in the data world today. This world is rapidly evolving. Like a few years ago, analytics engineering didn't exist. Business analytics and data analytics used to be kind of mushed into one. Now they're a little bit more segmented out. I'm sure as we go forward in the future, we'll see even more developments as we go, especially with AI. It won't just be data scientists, it'll be like AI engineers specifically, or machine learning engineers specifically as well. Hopefully this video gave you a little bit more insight into if you're considering getting into data or already on your data track, helping you identify what data path you may want to specialize in as you get closer to looking for a job or closer to making a switch from whatever you're doing now to getting into data. Just kind of a quick one. I hope you liked the video, and I will see you in the next one.